So-called is indeed included in the 40% fill calculation for conduits, regardless of its increased insulation compared to regular wire bundles. The purpose of the 40% fill rule is to ensure adequate heat dissipation. Conductors generate heat when carrying electrical current. If too many conductors are packed into a conduit, the heat cannot dissipate effectively, leading to a rise in temperature. This elevated temperature can degrade the insulation of the conductors, potentially causing short circuits, ground faults, and even fires. The 40% fill rule is a safety measure designed to prevent these risks. It applies to all types of conductors installed in conduit, including so-called THHN and other insulated wires. The National Electrical Code, or NEC, provides guidelines for conduit fill. These guidelines are based on the cross-sectional area of the conductors and the conduit. The NEC specifies the maximum allowable percentage of the conduit's cross-sectional area that can be occupied by conductors. This percentage varies depending on the number of conductors in the conduit. For example, for 1 or 2 conductors, the maximum fill percentage is 53%. For more than 2 conductors, the maximum fill percentage is 40%. To determine the conduit size required for a specific installation, one must first calculate the total cross-sectional area of all the conductors to be installed in the conduit. This can be done by consulting the NEC tables, which provide the cross-sectional area of various conductor types and sizes. Once the total cross-sectional area of the conductors is known, one can then select a conduit size that provides sufficient space to accommodate the conductors while adhering to the 40% fill rule. It is important to note that the 40% fill rule is not just a recommendation, it is a requirement of the NEC, and failure to comply with this rule can result in code violations and potential safety hazards. In addition to the fill rule, there are other considerations when installing conductors in conduit. For example, the NEC specifies the minimum bending radius for conduits to prevent damage to the conductors during installation. The NEC also requires that conduits be properly supported and secured to prevent them from sagging or becoming damaged. Furthermore, it is generally not recommended to use so-called for permanent installations in conduit. So-called is designed for flexible applications, such as connecting portable tools and appliances. It is not designed to withstand the stresses and strains of being pulled through conduit. Additionally, so-called is more susceptible to damage from abrasion and moisture than individual conductors that are specifically designed for conduit installations, such as THHN wire. If a flexible cord is needed in a conduit system, it is preferable to use a Type MC cable. Type MC cable consists of insulated conductors enclosed in a flexible metal jacket. This type of cable is specifically designed for use in conduit and can provide a more durable and reliable solution than so-called. Type MC cable is available in a variety of sizes and configurations to meet the needs of different applications. It is important to select the appropriate size and type of MC cable for the specific installation. When installing MC cable in conduit, it is important to follow the manufacturer's instructions and the requirements of the NEC. This includes ensuring that the cable is properly supported and secured, and that the correct fittings are used to connect the cable to the conduit system. In summary, while it may seem convenient to run so-called through conduit for short distances to avoid splicing or adding junction boxes, it is generally not recommended due to the 40% fill rule, the potential for damage to the cord, and the availability of more suitable alternatives such as Type MC cable. Adhering to the NEC and using appropriate wiring methods will help ensure a safe and reliable electrical installation. Remember to always consult the latest edition of the NEC for the most up-to-date requirements and guidelines. The NEC is a comprehensive document that covers all aspects of electrical installations, and it is essential for anyone working with electricity to be familiar with its provisions. Moreover, it is crucial to understand the ampacity of the conductors being used. Ampacity refers to the current carrying capacity of a conductor, which is the maximum amount of current that a conductor can safely carry without overheating. The ampacity of a conductor is determined by its size, material, and insulation type. The NEC provides tables that list the ampacity of various conductor types and sizes. It is important to select conductors with an ampacity that is sufficient for the load they will be carrying. If the conductors are undersized, they can overheat and potentially cause a fire. In addition to the ampacity of the conductors, it is also important to consider the ampacity of the overcurrent protection devices, such as circuit breakers and fuses. Overcurrent protection devices are designed to protect the conductors from overloads and short circuits. They will trip or blow if the current exceeds their rated ampacity. It is important to select overcurrent protection devices with an ampacity that is appropriate for the conductors they are protecting. The ampacity of the overcurrent protection device should not exceed the ampacity of the conductors. It is also crucial to ensure that all electrical connections are properly made and tightened. Loose connections can create resistance, which can cause the connections to overheat and potentially lead to a fire. All electrical connections should be made using approved connectors and tools. The connections should be tightened to the manufacturer's specifications. Furthermore, it is essential to protect electrical wiring from physical damage. Wiring that is exposed to physical damage should be protected by conduit or other suitable means. Wiring that is buried underground should be buried at the proper depth and protected from moisture and corrosion. In addition to these general safety guidelines, there are also specific requirements for different types of electrical installations. For example, there are specific requirements for installing wiring in hazardous locations, such as areas where flammable liquids or gases are present. There are also specific requirements for installing wiring in wet locations, such as bathrooms and kitchens. It is important to be familiar with the specific requirements for the type of electrical installation being performed. When working with electricity, it is always important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It also includes energizing circuits before working on them. If it is not possible to energize a circuit, it is important to use insulated tools and equipment. Electricity can be dangerous, and it is important to take all necessary precautions to protect oneself from electrical shock and other hazards. Remember, electrical work should only be performed by qualified and licensed individuals. If you are not qualified to perform electrical work, it is best to hire a professional electrician. A qualified electrician will have the knowledge and experience to perform the work safely and correctly. The electrician will also be familiar with the NEC and other applicable codes and standards. They will be able to ensure that the electrical installation is safe and compliant with all applicable regulations. When hiring an electrician, it is important to check their credentials and references. Make sure that they are licensed and insured. Also, ask for references from previous customers. A reputable electrician will be happy to provide you with references. In addition to hiring a qualified electrician, it is also important to have regular electrical inspections performed. Electrical inspections can help to identify potential problems before they become serious hazards. A qualified electrical inspector will be able to identify frayed wires, loose connections, and other potential problems. They will also be able to ensure that the electrical system is compliant with all applicable codes and standards. Regular electrical inspections can help to prevent electrical fires and other hazards. Electrical safety is a serious matter, and it is important to take all necessary precautions to protect oneself and others from electrical hazards. By following safe work practices, using appropriate materials and equipment, and hiring qualified professionals, it is possible to minimize the risk of electrical accidents. Remember to always consult the latest edition of the NEC and other applicable codes and standards for the most up-to-date requirements and guidelines.